Raycasting is an important technique in game development. This is one of the most important tools in your arsenal as a game developer. And the basic idea is we're just casting a line in 3D space from one spot to another. And we're just checking to see if it intersects any objects. This can be used for interaction with objects, like if you're looking around and you want to find out what the player is actually looking at, we can cast a ray right in front of the player and see what object it hits. We can use this for shooting, like for tracing the path of bullets. We can use this for line of sight checks, and this is used very often in enemy behavior and controlling how NPCs act. And there's a lot of other uses for them. Now we have three main commands here. There's the world pick method, the camera pick method, and the entity get visible method. So the world pick method, this casts a ray between 2 points. You have the start point and the end point. You have an optional radius, and if the radius is 0, then it's just a line that you're testing. If it has a radius greater than 0, then it actually tests the path of a sphere. So it's a little bit different. We have an option for that will allow us to either return the closest object that is hit, or if this is set to false, like it is by default, then it will just return as soon as any object is hit. And there's also an optional filter function. We'll talk about that in a minute. And the thing that gets returned from this is this pick info structure. The pick info structure contains an entity, and if this entity is null, then that tells you that nothing was hit. If there is an entity, then that tells you that something was hit. So that's how we tell whether the raycast intersected anything. There's also a face parameter. This is used if a brush was the intersected object. There's a mesh parameter. This is used if the intersected object was a model entity. And some other information. The really important stuff here is the position and the normal. We frequently use these. This gives you the position that the intersection occurred at, and the normal gives you the normal of the surface at the intersection position. Okay. Now the camera pick command is very similar. It just takes a screen coordinate and a frame buffer instead of 2 points, and it just figures it out. It just figures out the 2 points to use based on that using camera projection. And then we have the entity get visible method, and this is just a simple method that performs a raycast between two objects, and it returns true if nothing is hit, and it returns false if something was hit. It doesn't give you any more information than that. It's just a simple test to check visibility between two objects. So we have an example here that demonstrates line of sight testing really well. Let's just copy it. And then we're going to paste this into main.lua in a new project. And when I press the up and down arrow keys, then you can see right now the line between these two objects is occluded by this wall right here. But if I get just a little bit higher, then it changes colors. You can see the point where the objects can see each other, and it's based on a line through their center. It's not based on their exact edges. It's just the center of this object and the center of that object. We're just tracing a line right through them. And the code here, well, first we create two boxes here, box 1 and box 2. And then here we're just saying box 2 get visible box 1. And if they are visible, then we set the color of both objects to green. If they're not visible, then we set the color of both objects to red. This is red, green, and blue. So this is green, this is red. So that's the get visible method. Very simple. Now we have a nice example that shows use of the world pick command. So I'll run that first. So the starting point of the raycast is right here. And the ending point is at the end of this rod here. And then if we hit anything, then that green ball is going to be moved to the intersection point to show us where that intersection occurs. So let's take a look at how this works. So we have this pivot we created, this pivot entity, and we're just turning it 0.5 degrees every frame. And then we get the target position, and we do that by transforming a point. That's going to be 0, 0, and then rod scale. What is rod scale? We have it set to 5 meters right here. So this is X, Y, and Z. So this is a point that is 5 meters in front of this pivot. And the pivot is constantly rotating. So that target position is going to rotate around the pivot. And that's the end of the raycast. So here we have the world pick command. And we're going to use the pivot position as the first point. And then this target position that we calculated as the second point. We're setting the radius to 0, and we're setting this closest parameter to true because we want to actually return the closest intersection that occurs. And then down here we say, we get this pick info object, and then we say if pick info entity, that means if the entity is not null, then sphere set position at the pick info position. This is the intersection point. And if pick entity is nothing, then we're going to set the sphere at the target position, which is the end of the raycast, right? So let's take a look at that again. Here, this right here is the pivot position. This is the starting point of the raycast. And then the end of this rod is the end point of the raycast. And if any intersection occurs, then this green sphere gets repositioned at the intersection point. Let's see, we created this sphere with a radius of 0.25. So let's try changing the raycast radius to 0.25. So now instead of testing a line in 3D space, we're testing a sphere going through 3D space like it's a bullet that's being shot. Let's take a look at what that does. You can see the slight difference here. Yeah, now it's actually testing a sphere. It's doing a sphere cast. And so the pick position is the position that sphere is at the point where the sphere intersects the object. A little bit different. So this can be used to add a little bit of volume to an object. Like, for example, you might use, if you're doing bullets, if you're tracing the path of a bullet, you might use a radius of 0. If you're tracing the path of something bigger, like a rocket fired from a rocket launcher, then you might want to use a small radius because it'll look a little bit strange if it's a larger object and the sides of it go through the sides of a wall or something like that. So that's what the radius parameter does. Now I want to show you this the effect of the closest parameter with this example. And when I hit the space key, we're going to perform a pick, a raycast with the world pick method. We have the radius set to 0.5, but we have this closest parameter set to false. And so when we do that, it's going to, this this pick method will return as soon as anything is hit. It won't necessarily find the closest intersection point. It might, but it might not. It'll just return from the function as soon as anything is hit. So it won't necessarily give us the closest intersection. It'll just tell us if anything was intersected. And what we're going to do is we're going to start over here, and we're going to, this is going to be the first position of the raycast, and then we're going to, the second position is going to be somewhere over here. And when I hit the space key, you can see because it doesn't find the closest the closest intersection. So in this case, this is the first object that gets intersected, and so it just quits after that. Now if I set this closest parameter to true, then it should actually keep going and find the closest object. There you go. So if we're tracing the path of a bullet, then we want to actually have the closest, we want to make sure we have the closest intersection point then, because that's really important in that case. If we're just testing for a line of sight of visibility and we don't really care about the object that gets intersected, like we would do, like if we were checking to see if an enemy can see the player, we don't really care what object is occluding their vision. We just want to know if anything is in the way. In that case, we can set that closest parameter to false. And the reason we would actually do that is because it's going to be a little bit faster, usually, because it doesn't have to keep going and keep testing to find the closest parameter. It can just exit as soon as possible. So don't find the closest intersected object unless you actually need it for something. So it really just depends on what you're doing with that raycast. Now each entity has a pick mode, and it can be one of three values. You can have the pick mode set to pick none, which means the object just won't interact with raycasts at all. You can have it set to the collider pick mode, in which case if it has a physics collider, then that physics collider will be used for the intersection test instead of the mesh geometry. And in some cases that can be faster, like in the case of a sphere, that's a very simple mathematical formula. It's a sphere object is very, very fast to test, but a sphere mesh, depending on how detailed it is, can be very expensive to test. So in many cases, using the collider can be much faster. We don't always have a perfect collider that perfectly conforms to the geometry of the object, but sometimes we do. And these primitive creation functions like create box, create cone, create sphere, these all assign a collider when the mesh is created, and by default they're all going to use this collider pick mode just because they do have that perfectly conforming physics geometry. You don't always have that, but when you do have it, it's nice to use because it's more efficient. And then finally there's pick mesh, and this will do an intersection test on every triangle in the mesh. There is some optimization there, so it doesn't have to actually loop through and test every single triangle. There's an optimization structure for that, but it will give you a perfect intersection point of the entire mesh, finding the closest point within that mesh that intersects. And this is all controlled with the entity set pick mode method. We also have an optional filter function, and if you supply this filter function to the world pick command, then you can use this to control which objects actually get tested. So if this ray filter function returns true, then the raycast routine will go ahead and continue testing that object. If this ray function filter returns false, then it will just skip that object. And the criteria for that is up to you. You can use it to filter objects any way that you like. So now let's have some fun. Let's make, we've been doing some bouncing laser examples, and now we have one that's a lot more advanced. I'm just going to copy this and then paste it in here. And what I'm doing here is, this is just like our last example, except we're taking that intersection point from the pick info structure, and we're taking the pick normal, and then we're calculating a reflection vector, because we have this vector of the initial, the vector between the origin of the raycast and the final position of the raycast. That's one vector. And then the second vector is our pick normal vector that we get from the pick info structure. And then we can use that reflect method that we learned about to calculate the actual reflection director, and we can make we can make something that looks like a laser beam bouncing back off. So here's the world pick method being called, and then we say if the entity is not null, then we'll set the sphere position in the picked position just like before, and then we're going to calculate this reflection vector, and then we have this other object called bounce, and we're just going to align it to that vector, and that's what gives us our laser bounce. And this will work on every surface in every level. I have one more really nice example for you. Let's copy that in. And I'm actually going to change this up a little bit before we run it. This is a third-person camera example. Okay. First, I just want to show you without any raycasting. Here's our third-person camera example. So one problem we have here is if there's an object in between the player and the camera, we can't see we can no longer see the gameplay. And we can try to plan out our levels so that never happens, but that's going to be pretty difficult. We're always going to run into situations where something in the level blocks the camera's view. So to deal with that, what we can do is perform a raycast that starts right where the player is, right around where their head is, and then we can move that raycast backwards away from the player to the final position of the camera, where we are right now. And if that raycast hits anything, we can stop the camera there. And that should prevent any objects from going in between the player and the camera and occluding the view like this. So let's try it. Here's the world pick method, and this is starting. Okay, well first we set the camera position, and we're going to set it at the player position, and then we're going to raise it up vertically by a distance of 1.8. So this will place the camera right around the top of the player's head. And we have this camera rotation that we're setting ahead of time. So we're positioning and rotating the camera first, and they're going to be like right at the player's head. And then we're going to transform a point from the camera to world space. So that point is going to be 0, 0, and negative max camera distance. What is max camera distance? We have this set to 5 meters. So this is going to be a point that's directly behind the camera after the camera is first positioned right on the player and rotated. Then we're going to move a point backwards, and that's going to be the second point in our pick command here. So we're going between the camera position and this final position. We're going to set the radius to 0.25, and we definitely want to make sure that we find the closest intersected object in this case. And then if the pick info, if it hits any entity, if this entity is not null, then that camera distance is going to be the distance between the camera position and the pick info position, right? And if nothing is hit, then we're just going to apply some smoothing, and we're going to move the camera back away from the player up until it gets to the max camera distance of 5 meters. So after we have this camera distance, then we apply it to the camera, and we just move it backwards by that distance, whatever it is. So let's take a look at this. And now, when I go behind a wall, the camera just instantly jumps up so that there's nothing hiding the player. And one thing I just want to point out is when the player is occluded, we want the camera to instantly jump up, right? And when the camera comes, that opens up and there's no longer anything blocking it, then we gently move the camera away. You see that, how this is sudden, and then when we move back to the right, it's got a little bit of smoothing applied to it. And just in general, in video games, it's usually a good idea to apply smoothing. It just makes the motion a lot better for the player. However, in this case, if something's actually blocking the camera, we wouldn't want to apply smoothing to that, because having the camera fly through that wall is worse than having it just instantly jump up like that. So these are just a few of the things you can do with Raycasts. It's a really powerful tool. Pretty much every game I can think of will use it frequently. So make sure you understand it, and we're available for any questions that you have on the forum or on Discord.